There's a simple combination of brick and sand that creates garden paths so indestructible they'll outlast your house, never sink into the ground, and never grow a single weed. This isn't about expensive pavers or complicated concrete work. I'm talking about an ancient technique that landscaping companies have quietly erased from public knowledge because it's too simple, too cheap, and too permanent for their business model. They'd rather charge you $30 to $80 per square foot for work you can do yourself for $3 to $5 per square foot using materials you can often get for free. But what I'm about to show you isn't just about saving money. It's about understanding why this method works so well that paths built this way in medieval Europe are still solid after 800 years, while modern concrete walkways crack and sink within a decade. The reason landscaping companies don't want you to know about dry-laid construction is that it requires no special equipment, no expensive materials, and once it's done, it never needs repair. There's no ongoing maintenance contract, no seasonal resealing, no replacement schedule. Just a path that gets better with time instead of worse. But the real secret isn't just in the materials, it's in understanding the physics of why rigid structures fail and flexible structures last forever. Most people think that the strongest path is the one made with the most concrete, the deepest foundation, the most expensive materials. They couldn't be more wrong. The strongest structures are the ones that can move without breaking. A dry-laid brick path isn't fighting against the natural movement of the earth, it's working with it. When the ground freezes and thaws, when tree roots grow, when soil settles, the path adjusts and flexes instead of cracking apart. This is the same principle that allows ancient Roman roads to still exist, while modern highways need constant repair. The foundation of this system starts below ground, and it's not what you think. Instead of trying to create an immovable base with concrete, you're creating a drainage system that prevents the problems that destroy other paths. The first layer is 2 inches of compacted sand, not concrete. This sand layer does something that concrete can't. It drains water away from the foundation while providing a stable but flexible base. Over the sand goes landscape fabric, but not the flimsy stuff from the hardware store. You need commercial-grade geotextile fabric that's designed for road construction. This fabric does 2 things. It prevents the upper layers from mixing with the soil below, and it allows water to drain through while blocking weeds from growing up from underneath. This single layer solves the weed problem before it starts. The next layer is the secret to why these paths never sink. 4 inches of crushed stone, not gravel. The difference matters. Crushed stone has angular edges that lock together when compacted, creating a surface that can bear enormous weight while still allowing water to flow through. Gravel has rounded edges that roll over each other and eventually sink into soft spots. The crushed stone creates what engineers call a load-bearing surface that distributes weight evenly across the entire path. On top of the crushed stone goes another layer of sand, but this time it's only an inch thick and it has a specific purpose. This is your leveling course, the layer that allows you to make the brick surface perfectly even, despite variations in the foundation below. You'll screed this sand level using a straight board, creating a uniform surface that ensures your finished path won't have high spots or low spots that collect water. Now comes the brick installation, and this is where most people make their first mistake. They think you just lay bricks down and you're done. The secret is in the spacing and the pattern. Bricks should be laid with consistent gaps of about a 1/4 inch between them. This gap serves 3 purposes. It allows the path to flex without binding, it provides room for the jointing sand that locks everything together, and it creates drainage channels that prevent water from pooling on the surface. The pattern you choose affects more than just appearance. A herringbone pattern is the strongest because it locks the bricks together mechanically, preventing individual bricks from shifting under load. Running bond patterns look clean but are less stable because the bricks can slide along their length. Basket weave patterns are attractive but create weak points at the corners where four bricks meet. Have you ever tried building a garden path that lasted more than a few years? Drop a yes or no in the comments. The real magic happens with the jointing material, and this is where the method gets revolutionary. Instead of plain sand, you're using a mixture of sand and cement in a 10-to-1 ratio. This isn't wet concrete that hardens immediately. It's a dry mixture that gradually absorbs moisture from rain and humidity, slowly hardening over time to create permanent joints that weeds cannot penetrate. The beauty of this system is that it happens naturally. You don't need to wet it down or time the installation around the weather. You just sweep the mixture into the joints and let nature do the rest. This hardening process takes about 6 months to complete, during which time the path remains flexible and adjustable. If a brick settles slightly or shifts out of alignment, you can easily tap it back into place. But once the sand-cement mixture has fully cured, the joints become as hard as concrete while maintaining their ability to handle small movements without cracking. The material costs for this system are shockingly low compared to what landscapers charge. Used bricks, which work perfectly for this application, cost 50 cents to $2 per square foot depending on your area. Construction sand runs about $30 per ton, enough for several hundred square feet of path. Crushed stone costs about $40 per ton. The most expensive component is often the geotextile fabric, but even that runs only about 50 cents per square foot. Compare that to the $30 to $80 per square foot that professional installation costs, and you're looking at a savings of over 90%. But the real value isn't just in the initial savings. Concrete paths require resealing every few years, crack repair, and eventual replacement. Mortar joints between traditional pavers fail and need repointing. Asphalt paths need resurfacing. A properly built, dry-laid path requires no maintenance for decades. The only thing you might need to do is occasionally add more jointing material if heavy rains wash some away, and even that becomes unnecessary once the sand-cement mixture has fully hardened. If this is making you rethink your landscaping plans, hit that subscribe button and give this video a thumbs up. There's so much more to learn about building things that actually last. The installation process is straightforward, but requires attention to detail at each step. Start by marking out your path with spray paint or stakes and string. The width should be at least 3 feet for a main path, wider if you want 2 people to walk side by side comfortably. Excavate to a depth of 8 inches below your finished grade. This seems like a lot of digging, but it's what separates a permanent path from one that will sink and shift within a few years. The excavation needs to be precise. Use a transit level or a long straight edge with a level attached to ensure consistent depth. The bottom of the excavation should slope slightly toward one side to encourage drainage, about a 1/4 inch drop per foot of width. This subtle slope prevents water from pooling under the path during heavy rains. Compact the soil at the bottom of the excavation using a plate compactor or hand tamper. This step is crucial and often skipped by DIYers who are eager to get to the visible parts of the project. Uncompacted soil will settle over time, creating low spots that lead to problems later. Spend the time to compact every square foot of the excavation bottom. Add the 2-inch sand base in lifts, compacting each inch separately. Don't dump all the sand at once and try to compact it in one pass. Sand compacts differently at different depths, and you need uniform density throughout the base layer. Use a plate compactor for best results, making multiple passes until the sand doesn't visibly compress anymore. Roll out the geotextile fabric with overlaps of at least 6 inches at the seams. The fabric should extend up the sides of the excavation to prevent contamination from the surrounding soil. Use landscape fabric pins to hold it in place temporarily, but don't puncture it unnecessarily. The goal is to create a continuous barrier that water can pass through, but soil cannot. The crushed stone goes down next, again in lifts for proper compaction. 4 inches might seem excessive, but this layer is doing the structural work of your path. Skimping here leads to settling and failure later. Use 3/4 inch minus crushed stone, which contains a range of particle sizes that lock together when compacted. Avoid clean gravel or single-size stone, which doesn't provide the mechanical interlock you need. The leveling sand goes on last, and this is where precision matters most. Use fine mason sand or concrete sand, not coarse sand or sand with clay content. Screed it level using a straight 2x4, notched to the depth you want. Work in small sections, laying bricks as you go so you don't walk on the screeded sand and disturb the level surface. Lay bricks starting from a straight edge like an existing patio or a temporarily installed screed board. Work across the width of the path before moving forward, maintaining consistent spacing using wooden spacers or simply judging by eye if you have experience. Tap each brick into place with a dead blow hammer or rubber mallet, listening for the solid sound that indicates good contact with the sand bed. Check your work frequently with a level, both across the width and along the length of the path. Small adjustments are easy to make during installation, but difficult to fix later. If a brick sits too high, remove it and scrape away sand underneath. If it sits too low, add sand and re-level that section. The edge restraint is critical for long-term stability and often overlooked by amateur installers. The bricks at the edges of your path are under the most stress and most likely to shift if not properly supported. You can use steel edging designed for pavers, pressure-treated lumber, or even a row of bricks set vertically in concrete. The key is that the edge restraint must be below the surface of the finished path and anchored securely to prevent outward movement. Once all bricks are in place, sweep the sand-cement mixture into the joints using a push broom. Work diagonally across the surface to ensure complete filling of all joints. The mixture should be dry when applied and should fill the joints completely from top to bottom. Don't worry about getting some on the surface of the bricks. It will wash off with the first rain. Compact the entire surface with a plate compactor fitted with a rubber pad to prevent damage to the bricks. This final compaction seats the bricks firmly into the sand bed and helps settle the jointing material. Make several passes in different directions, but don't overdo it. Over-compaction can damage the bricks or disturb the carefully leveled sand bed. The curing process begins immediately, but takes months to complete. During this time, avoid heavy traffic and don't be concerned if you see some settlement or minor shifting. This is normal and expected. The path will actually get stronger and more stable over time as the jointing material hardens and the various layers settle into their final positions. Weather affects the curing process but doesn't stop it. Rain helps activate the cement in the jointing mixture, while dry weather allows excess moisture to evaporate and prevents over-rapid curing that can lead to weak joints. Freezing temperatures slow the process, but don't damage it. The flexibility of the dry-laid system means freeze-thaw cycles actually help lock the components together rather than destroying the structure. Maintenance during the first year consists mainly of adding jointing material if heavy rains wash some away, and occasionally re-leveling any bricks that settle more than others. These adjustments become less frequent over time and eventually stop altogether as the system reaches equilibrium. After the first year, maintenance is essentially zero for a properly installed dry-laid path. The longevity of this construction method is proven by examples around the world. Medieval town centers throughout Europe still have brick streets built using these techniques. Colonial-era paths in America built this way are still in use after 300 years. The Roman roads that still exist today were built using similar principles, just with stone instead of brick. These aren't archaeological curiosities. They're functional infrastructure that has outlasted multiple generations of quote, zero, replacements. The environmental benefits of dry-laid construction extend beyond just material savings. The permeable nature of the system allows rainwater to infiltrate naturally instead of creating runoff that contributes to erosion and flooding. The thermal mass of brick and stone helps moderate temperature swings, creating a more comfortable microclimate around the path. And because no concrete is used, the installation has a much smaller carbon footprint than conventional paved surfaces. The versatility of the system allows for creative variations without compromising structural integrity. Different brick patterns create different visual effects while maintaining the same underlying strength. Mixed materials, like brick and stone, can be combined for decorative effects. Curved paths are possible by cutting bricks to fit the curves. Those straight runs are stronger and easier to install. Common mistakes that lead to failure include inadequate excavation depth, poor drainage, insufficient compaction, and using the wrong materials. The most frequent error is trying to rush the process or skip steps to save time or money. Each layer serves a specific purpose, and eliminating any component compromises the entire system. Another common mistake is trying to use this method in areas where the water table is high or drainage is naturally poor. Even the best dry-laid path will fail if water cannot drain away from the foundation. Troubleshooting problems usually involves going back to basics and checking each layer. If bricks are settling unevenly, the issue is probably inadequate compaction of the base layers. If weeds are growing through joints, the geotextile fabric may have been damaged or omitted. If edges are spreading, the edge restraint is insufficient. Most problems can be fixed by removing the affected area and rebuilding it properly, which is much easier with a dry-laid system than with concrete construction. The seasonal performance of dry-laid paths actually improves over time rather than degrading. Winter freeze-thaw cycles that destroy concrete actually help lock dry-laid construction together more tightly. Summer heat that causes concrete to crack and shift has no effect on properly built dry-laid surfaces. Spring water that undermines conventional foundations drains harmlessly through the permeable base of a dry-laid path. Advanced techniques for challenging installations include dealing with slopes, incorporating drainage systems, and transitioning to other surface materials. Slopes require more careful attention to base preparation and may need terracing or retaining walls for stability. Drainage systems can be integrated into the crushed stone layer using perforated pipe and additional gravel. Transitions to concrete, asphalt, or other materials require careful detailing to prevent differential settling. The economics of DIY installation versus professional work become even more favorable when you consider the learning value. Building your own paths teaches skills that apply to many other landscape and construction projects. Understanding the principles of drainage, base preparation, and structural design helps you evaluate contractor proposals and avoid costly mistakes on future projects. The confidence that comes from successfully completing a major landscape project encourages tackling other improvements that would otherwise require professional help. Professional contractors who still use traditional dry-laid methods are becoming rare, partly because the technique doesn't generate ongoing revenue, and partly because modern construction education emphasizes concrete and engineered systems over time-tested traditional methods. Finding a contractor who understands proper dry-laid construction can be difficult and expensive, making the DIY approach more attractive even for those who can afford professional installation. The tool requirements for dry-laid installation are minimal compared to other construction methods. A plate compactor is the most expensive tool needed, but it can be rented for the few days required for installation. Basic hand tools like shovels, rakes, levels, and hammers are sufficient for most of the work. A wheelbarrow or small dumper makes material handling easier but isn't essential. Compare this to concrete work that requires mixers, forms, finishing tools, and precise timing, and the accessibility of dry-laid construction becomes clear. Material sourcing for DIY projects often involves creativity and patience. New bricks are expensive, but used bricks from demolished buildings, old chimneys, or renovation projects can often be obtained cheaply or even free. Construction sand and crushed stone are commodity materials available from any concrete supply yard. Geotextile fabric can be ordered online or purchased from landscape supply stores. The key is planning ahead and watching for opportunities to acquire materials at low cost. Quality control in DIY projects requires honest self-assessment and willingness to redo work that doesn't meet standards. Each layer should be checked for proper depth, compaction, and levelness before proceeding to the next. Taking photos during construction helps document proper installation and can be useful for troubleshooting if problems develop later. Measuring and documenting material quantities helps with ordering materials for future projects and provides data for estimating other work. The psychological satisfaction of building permanent improvements using traditional methods that connect you to centuries of craftsmanship adds value beyond the mere functional and economic benefits. There's something deeply satisfying about working with simple materials and hand tools to create something that will outlast modern, engineered alternatives. This connection to traditional building methods provides perspective on why old buildings and infrastructure often outlast their modern replacements. Long-term performance data from existing installations provides confidence in the method's reliability. Properly built dry-laid paths that are 50 to 100 years old show minimal wear and require no structural maintenance. The gradual settlement and adjustment that occurs in the first few years actually strengthens the installation by eliminating weak points and creating tighter interlocks between components. This self-improving characteristic is unique to flexible construction methods and impossible to achieve with rigid systems. The design possibilities within the constraints of traditional dry-laid construction are nearly unlimited. Different brick sizes, colors, and textures create varied visual effects. Mixing brick with natural stone adds interest while maintaining structural integrity. Incorporating planting areas, steps, or seating areas is straightforward with dry-laid construction. The modularity of the system makes modifications and additions easy even years after initial installation. Future maintenance needs are minimal, but worth understanding. The most likely maintenance requirement is adding jointing material if heavy rains wash some away before the sand-cement mixture has fully hardened. After full curing, even this becomes unnecessary. Occasional cleaning with a pressure washer or stiff brush keeps the surface looking fresh. Individual bricks can be lifted and relaid if damaged, something impossible with concrete or mortared installations. The environmental impact of material choices affects the sustainability of the project. Local materials require less transportation energy and often cost less. Recycled bricks have lower environmental impact than new ones and often look better due to their weathered appearance. Natural sand and gravel have lower environmental impact than manufactured materials. Even small choices like using hand tools instead of powered equipment where possible reduces the carbon footprint of the project. Here's the truth that landscaping companies don't want you to discover. The best garden path isn't the most expensive one or the one with the most advanced materials. It's the one built using principles that have worked for thousands of years, adapted to modern materials and understanding. A path built with these time-tested methods will outlast your house, cost a fraction of professional installation, and require virtually no maintenance for decades. The transformation from thinking about landscaping as something that requires professional expertise and ongoing expense to understanding it as something you can master using traditional techniques and simple materials changes your entire relationship with your property. Instead of being dependent on contractors and maintenance schedules, you become capable of creating permanent improvements that enhance your property value and provide decades of service. Remember that every expert was once a beginner, and the principles of good construction are straightforward, even if the execution requires practice. Start with a small project to learn the techniques and build confidence. Document your process and results to improve future projects. Don't be afraid to ask questions or seek advice from experienced builders, but trust in the proven principles that have created lasting infrastructure for centuries. The choice between fighting the earth with rigid construction that inevitably fails and working with natural forces using flexible systems that improve with time represents a fundamental difference in philosophy that extends far beyond garden paths. Understanding these principles opens up possibilities for other projects and helps you evaluate construction proposals and materials with knowledge instead of guesswork. Have you ever built any kind of garden path or walkway before? Let me know in the comments what materials you used and how long it lasted. And if this has convinced you to try the traditional approach to path building, make sure to subscribe for more forgotten building techniques that actually work better than their modern replacements. Because sometimes the old ways aren't obsolete. They're just temporarily forgotten by industries that profit from selling you complicated solutions to simple problems.